So in this problem, we have to find the value of alpha if cot inverse of alpha is equal to cot inverse of 2 plus cot inverse of 8 plus cot inverse of 18 plus cot inverse of 32, so on and so forth. Well, if you try to find a pattern between these numbers, you may immediately notice that all of these numbers are 2 times the square of something, so 2n squared. And if you want to add a bunch of cot inverses together, you can always try to first divide them in a form that looks something like a minus b, and then you might get to see some cancellations. So you can write that cot inverse of 2i squared, you can write this as tan inverse of 1 over 2i squared. And now, since we know that to get a difference in tan inverse, we need to have something of the form a minus b divided by 1 plus a times b. What we can do here is try to write this as 1 plus 2i squared minus 1, and then something up here. But then you notice that if we multiply both sides, both the numerator and the denominator, by 2, that gives us tan inverse of 2 by 4i squared. You can write this as tan inverse of 2 by 1 plus 4i squared minus 1. And 4i squared minus 1 can be written as 2i plus 1 times 2i minus 1. And if you notice, the difference between these two algebraic expressions is equal to 2. So this can be written as 2i plus 1 minus 2i minus 1. And now if you break this can be written as tan inverse of 2i plus 1 minus tan inverse of 2i minus 1. Now, I goes from 1 to infinity, so we can write this expression now here. So if you write this again, so this will come out to be cot inverse of alpha is equal to, so firstly, for tan inverse of 2i plus 1, here instead of I you put I equals 1, so you will have tan inverse of 3 minus tan inverse of 1 minus tan inverse of 1, plus now you have I equals 2, so tan inverse of 5 minus tan inverse of 3, and so on. And the last term that wouldn't cancel would be tan inverse of infinity. Of course, that's really hard to say. There is some definite term like that, but all other terms, notice, will just get canceled out. So you will have a bunch of cancellations, and in the end, you will have tan inverse of infinity minus tan inverse of 1, just because this sequence goes to infinite terms. Tan inverse of infinity, well, that's equal to pi over 2, and tan inverse of 1 is equal to pi over 4. So now we know that pi by 2 minus pi by 4 is equal to pi by 4, and cot inverse of alpha is equal to pi by 4. So that means that alpha is equal to cot of pi by 4, or is just equal to 1.